So the XRD is slightly different from others. It is having its unique applications. And whenever you want to find out the cluster of informations like the orientation of the structure and the size of the structure and the dispersion of all these elements and what is the density in terms of percentage and all, if you want to find out, you can use this XRD, the X Ray Diffraction system. And specifically, whenever the crystalline materials, as I told you just now, they'll be having a d-spacing, that is a unique distance space for a particular material. The lattice distance it is, at times will be separated by this distance. And whenever the X-ray light is incident on this, and the reflected, that is diffracted beam, will have so many informations it will be carrying. It will be giving you the details of the size of item, the orientation of this, and how many have been scattered within a given space. All these will be the important informations we'll get. And basically the XRD machine consists of its manipulator, its arm. Okay, it can be moved to a required distance, required position by having a vertical limb arm. And a finely powdered or polished surface may be rotated against the center. That is goniometers. That is a sample which is located, which can be rotated, and we can able to get the data in terms of film or a strip or a magnetic medium or storage. Okay, and here also the same thing. We are not going to get any the colored informations of the image. Only the gray level will be informing you. That is a black and white combinations will be shown. And this will be showing you. This has been taken by NSTC. Okay, and now you can see that how basically the X-ray diffraction machine is working. A high voltage will be given, and through this X-ray tube, the X-ray will be beam of light is made to pass through this lead screen, and the crystal will be kept in between in front of lead screen. And the lead screen is one which it will be focusing the X-rays through a slit. The slit of this X-ray passing through this crystal, which will be diffracted. That is, it will be dispersed, and we can able to get a photographic plate. On this photographic plate, up to the magnification of more than 1 million, we can able to get on this, and anyone can able to see this. And another one, there is the flexible possibilities are also have been given to find out the diameter or the shape of the element or the shape of item, and what is the distance between these elements, and any other foreign materials are there. All those we can able to find out. Okay, that just like we do indentation test. Once after the indentation, we can able to find out what is the depth of indentation, diameter of indentation, the cone size, all this. In the similar way here, it's possible to find out all these informations we can. Okay, and the same thing I have given why this XRD is. And this will be measuring the average spacing between the layers of the rows and the items. And as I told you, the crystalline materials will be having the layers. The unique distance will be there between the atoms, and it can able to find out. And it can able to find out the orientation of a single crystal and grain. Very important. And some other the crystal structure of any other unknown materials we have added to make it as a composite. That also we can able to find, and it can able to measure the shape, size, and internal sources developed in the system. All these we can able to find out. This is what the X-ray diffraction machine is. And now we have come across the tool. This one, as I told you just a few minutes back, the cryogenically treated the tools, cutting tools. Okay, cutting tools. Those have been tested under this X-ray diffraction machine, and the level of composition and what is the how much the density of the other element have been added is dispersed, and what is the orientation and size. All these informations we can able to give. And another one, if you are going to slide over the surface of this tool, and the tool surface preparation is not much more important here. Once you slide over the tool, what happens? It will be getting you the average dispersion of the elements. For example, in one cabin, average, for example, the first test I did, I have 3, the second test 4, third test 3. The average of 3 is first, second, third, adding them together and divided by 3. In the similar way, the average cluster of the particles which have been spread over the sample, it can able to give the estimation. That also is possible. And that is all totally depend on how the person, what we require, and based on this we are going to set up the input data. Okay. And the principle of operation of the X-ray diffraction, just now I told you, it works on the Bragg's law. Okay, the incident light and the reflected light will have certain relations. Those relations will be building the size of the element which we have.